Now we have to have, in this case, check valves also on this system. So in this line, this downstream line, there has to be a check valve so that we don't get water pushed backwards through the pump and into the chemical mix. Here we're worried about the water going into the chemical instead of the chemical going into the water. We don't want to dilute that chemical in that tank. If the pump is shut off, we don't want to have water flowing up into that tank. Okay? And we also have to have a check valve on this side so that that pump is always flowing the green liquid down through the pump and then out through the system. When it strokes, it doesn't want to pump the liquid back into the tank. It wants to make sure that when the arm strokes through and forces the liquid out of its cavity, it pushes it downstream into the water supply, not backwards back up into the chemical holding tank. Pretty obvious, so we need a couple of check valves. To guarantee the flow always goes in the direction toward the pipeline. And it's that simple. And the check valves are actually built right into the pump, so you don't even have to apply them. They're already there. One on the suction side of the pump, one on the discharge side of the pump. Now also another thing is the chemical tank has to be higher than the pump. These pumps do not have suction capability. They cannot pull a vacuum. They cannot suck the liquid into them. It has to be force fed into them. So you can see our little stand over here, we got about a 3 foot, 2.5 to 3 foot elevation drop. We're literally forcing the water down into the pump itself. And then the downstream side, the pressure end over here, that can be extremely high pressure. These hoses, because they're suction hoses, on the suction side have to be stiff hose. And when we go over here and look at this tank, you'll see that it is a rigid hose. It cannot collapse. The downstream side can be collapsible, but the downstream side has to be able to withstand very high pressure. So it has to be high pressure hose on the downstream side, a different kind of tubing. And we're only talking 1/2 inch tubing or 3/4 inch tubing on these units. So we're talking very small flow rates, a few ounces a minute, but very accurately measured in to the water. A few other apparatus that we have to be concerned about are, number one, mixing tanks. Why do we need mixing tanks? Anybody know? Some of you know.
Because there's usually more than one chemical in there.
Okay, sure, oftentimes we might be blending more than one chemical. We might be putting 2 kinds of fertilizer together. Would be a pretty common thing. You know, maybe we're going to put nitrogen and a trace mineral in there. Or we're going to put nitrogen and maybe we're going to inject some potassium. If they're compatible. Of course, we have to check and make sure when we do mix dislike materials that they're going to be compatible and they don't settle out or precipitate out. Also, we have to be able to mix, because some of these chemicals, if you don't keep them mixed, they're heavier than water, they'll separate. You know, liquid nitrogen fertilizer is quite a little bit heavier than water. So if you had a blend and you were injecting a blend of these chemicals, you don't want them to separate. You want to keep the mix the same all the time. So you need a mixing tank with an agitator. And what they'll do is there'll actually be a motor with a paddle moving around in that tank, and it just keeps the liquid stirred constantly.
Some of them will solidify as well.
Yeah, sometimes they're going to precipitate out anyhow, but we try to keep that from happening. We need control valving, and we've talked about the control valving. We have to make sure we have the backflow prevention and the proper check valves, and, like the Venturi, the proper on and off valves so we can divert the liquid the direction we want it to go. You know, another thing besides the check valve here, we definitely want to put in some kind of a stop valve, a gate valve or a ball valve also, so that we can just shut it off. Because we don't want this tank draining out through the pump just by gravity, and it would if it had the opportunity. So we have to also be able to totally isolate. And if we want to do maintenance on the tanks and so on, there could be other places that we might need to place control valves so that we can isolate different parts of the system. If we have to clean a hose, we want to be able to isolate right at the tank with a ball valve of some kind probably, so that we can remove the hosing, take the pump, and move the pump somewhere. Those pumps cost a lot of money, $1,000, $1,500. We don't have to leave it at one site. It's a real bugger to move that 500-gallon tank, but it's real easy to move that pump from one location to another if we're spreading the chemicals around a different farm. We can use one pump on quite a few different fields in agriculture. Now in turf, we're probably going to have all set up as a stationary unit in place, one injector pump at the pump site, and it will be a built-in system. But in ag, it's going to be quite portable, because we'll probably move it from field to field to field.